Okay. There you go, Mike.
You want to go ahead? Okay. Can you hear us okay? Oh, you need a mic?
Need a mic?
Yeah, all right. Dave.
Well, as Dick said, my name is David Harris. I work with the Struma Area Council of the Boy Scouts, and I'm here to thank a couple of groups of people for some tremendous support we've had in the last year. Last year at summer camp, as well as at our winter camp program here just a month or so ago. We had John and who else was out over the summer and at winter camp to help make this happen?
Hey, anyone that participated with the Boy Scout training, why don't you come on up forward
please,
here?
come on up.
Buddy, but I think he's in the other
Yeah,
room.
he's
in this room.
testing right now.
And Brooke is not here yet. So why don't you
Well, this summer we offered the radio merit badge with the help of John and others for how many scouts did we have over the course of those 3 weeks?
We had probably 10 to
Yeah.
15.
And then again, just last month at our winter camp program, there were another, how many? 7? And that wouldn't have been possible without the help of your group and the LSU club. And I have a certificate here for each of the clubs in appreciation for all of the support that you gave us this past year, and really appreciate your support and
Thank
making
you.
this all possible for these young men.
Thank you, David.
Yeah, one more. And Dana just walked in, and Daniel, if y'all would come up.
Yes,
for a minute.
please.
I know you don't like recognition. Excuse me. But I want to say thank you to the LSU Radio Society. While they may have not been on the front line actually working with the scouts, their support, they volunteered to help, got some materials. Daniel was scheduled to come up, but thanks to John, at winter camp, all the boys made their 10-minute QSO of the 6 or 7 that we had. So appreciate your support. And on behalf of the Struma Area Council, we'd like to go ahead and recognize LSU Radio Society, who works very close with our club here, Baton Rouge Amateur Radio Club. Thank you.
Hey, Daniel, hold the certificate up when you get pictures taken.
Yeah. Well.
Thank you, appreciate you. being here.
Absolutely, thank you.
I'm collecting dues for 2016, so anybody who wants to pay me can pay me tonight. You can also pay online with a credit card if you want to. So we'll take cash, check, or credit
These dues
card.
are $25, and we've gone to a system where they're due at the first of the year. We used to have the dues would fall at various anniversaries, but now all the dues are due at the first of the year, so to kind of keep things easily managed. The board is still looking at the issue of the best location ongoing for the regular meetings, and they'll be looking at that again with the next the February board meeting. But I think, in my opinion at least, it'll be the board's final decision. But in my opinion, the next meeting, which is the program schedule, is going to be a program put on by Red Cross regarding disaster assessment. I think we probably ought to plan that meeting will be here at the Red Cross. So if there are any changes after the board meeting, we'll get the word out to everybody. But at least for now, I think we need to plan that the next meeting will be as originally scheduled here at Red Cross. Any other announcements? I know Buddy is next door, but the general upgrade class is ongoing. I know that it's meeting on Thursday evenings at the main library in Goodwood, 7 o'clock. Excuse me, 6 o'clock, I beg your pardon. That's right, 6 o'clock. So I plan to get over there myself just kind of as a refresher. I think it'd be good for me. But they had what? They had several, they had 10 students. And so it got out of their way last Thursday. This Thursday will be the second. Goes on for what? 10 weeks?
10 weeks.
10 weeks. And at the end of that class, there'll be an exam session offered. A VE session will be offered. And I don't know the details just yet on the VE session, but we'll have another VE session there.
And then let me just say, if I could just say something else about the classes. What Buddy is talking about is running another technician class. Technician classes are great for grooming, grooming the non-hams and getting them into the hobby and getting them into the club. And we've picked up a lot of new members that way. So we'll be running that in the summer. And we are thinking about an extra class in the fall. And I don't know, we may put a survey out and we may kind of poll the membership and see how many people would be interested in going for an extra class. Let me just ask the guys here, who would be interested in, okay, I mean, that makes a class right there. And all we have to do is get the instructors and the books. They've just changed the books, so
Current book runs out in June.
well, in June. Now, the problem, if we don't run it in the fall, the reason we wouldn't run it is that we can't get the PowerPoints in time to start it in September. That's what happened with the general class. We were going to run this general class, we were going to run in the fall, but we couldn't get the PowerPoints in time. It took them a long time. They had the books done, but didn't have the PowerPoints. So we'll wait and see. We'll see what happens on that. But good, we've got a good idea that we've got enough people that want to take the class. The other thing I wanted to say real quickly, who's participating in National Parks on the Air? Good. Perfect. Brett just walked in, and Brett has got something to say. He's been doing a lot of work. Club is going to activate some of these sites and get club members to come out and operate. And Brett has been going around and he knows where the sites are. Why don't you come up here, Brett, and talk a little bit about what your plans are.
Yeah, just to activate using the W5 GIX call sign a couple times during the year. So we haven't set any dates yet. We're going to work out what's good time, coordinate with Dana and Field Day as well. But I think I am talking. We think there'll be an opportunity to do it a couple times a year. There's a couple locations within an hour, 2 hours drive of here. There's one in Lafayette. There's 2 or 3 in Natchez, Mississippi. There's another one in Ocean Springs that all qualify for the National Parks on the Air. You guys familiar with the National Park Service is celebrating their centennial, and so the ARRL is hosting an event along with that where you go and activate a park, but then you also can chase and communicate with folks that have activated the park. So I've had a lot of fun doing it. I think Dick, I've seen him on the leaderboard already. Jerry, I think we're tied on the leaderboard at the currently. So if you have any questions, feel free to ask. And I think we're shooting for possibly the first club event in March, I think, is when we're looking to do the first one.
Yeah, there's something like on the order of almost 500 administrative units under the National Park Service. And they're not all national parks. Some of these are military parks or historic sites, Natchez Trace being, for example. So they're not all national parks. There's some 50, some odd, 58 or 59 national parks. But you can activate any of the so-called administrative units, of which there are 468 or something along those lines, of those units. In Louisiana, we have several. So the one that we had talked about earlier was in Chalmette.
The Chalmette site, the Lafayette site, the Eunice site, all of those fall under the Jean Lafitte National Historical Park and Preserve. So they're all one administrative unit, but they have several sites.
We don't have national parks in Louisiana, but we do have several administrative units that we can activate. But it's fun. I've been chasing them a little bit.
Yeah, I've been having a blast.
Okay. Any other announcements? I've been sending out a lot of emails about the VP8 expedition. I guess pretty much most of y'all have been getting the emails. And the last I heard this afternoon was that they had recovered their equipment. They were all back on the ship and they were on their way, hopefully to South Georgia. I guess it's going to depend on the condition of the antennas and other equipment. But the last I have heard is that everybody's safe back on the ship. And but if you all didn't follow, yesterday they had an emergency evacuation of the island because a piece of ice had broken loose during the storm 2 days ago, and it threatened to block the bay. And had it blocked the bay, the Braveheart, the vessel they came in on, had no way to get them off the island.
Ain't no way to get out either.
No, well, it couldn't get into the bay, and it couldn't get out of the bay. So the owner, Nigel, I forgot his last name, the owner, and I guess the captain, pardon? Jolly. Nigel Jolly, the owner of the Braveheart, declared an emergency. So they all had to leave, and evidently, from what I gather, all their personal belongings and their radios, everything was left there. And they had to get on the ship and get the heck out before the ice closed things off. But conditions must have improved today, because the report is they're back on the ship, and their plan was now to go to South Georgia, which is about 600 miles north of South Sandwich. And hopefully they'll be able to continue their expedition, but that, of course, remains to be seen. I have a theory about the whole thing. My theory is that they have located the soundstage where the moon landing was filmed. And it's probably somewhere in the Caribbean, or maybe in the South Pacific, or maybe Miami. And all this is from that soundstage. That's just my theory about it.
I have a question. I looked at the video of the one you sent today, and it shows it's 1992.
Right.
Okay, so it wasn't a video of what's happening.
No, this was the 1990, but it's eerie how similar the conditions must have been, except the 1992, the winds were like 132 miles an hour, if I remember correctly, and on this occasion, the winds were like 70 miles an hour. And in 1992, the vessel that carried them to South Sandwich went back to South Georgia, 600 miles north. So when the 1992 expedition got in trouble, same kind of trouble that this expedition encountered, their rescue was 4 days away. So it was a little different situation. I mean, that was a very precarious situation. But there was a little wooden shack in whatever location they chose in 1992, had a small shack, which was a little rescue shack that had provisions and stuff. And it was for whalers and sealers and whatnot, fishermen that were in that area, where they could go and get into this shack. The shack had...
All their tents were blown down.
Yeah, tents were blown down and everything. But they got in the shack, and when they left, they replenished the shack, so it would be ready, so... But it had been a number of years since that shack had been used, and of course, the seals and the sea lions had been in the shack, and it took them 2 days to kind of clean it out. But at least they had some protection.
Dick, can we ask the group who was lucky enough to work at South Sandwich?
I know of only one, I think just came in, yeah.
The only, you want to tell us how you got them from? Because this is, I got no nagging, no linear.
Vernon got it.
So tell us how you got them.
It was easy. It was 2 a.m. Sunday morning. I got in on CW on 30 meters.
I worked
It's
David.
just
Oh, you
like everything, it's persistence.
Vernon worked them too, so we got
Of
two.
course, I worked them on 20, 40, and 15.
Oh, you did work.
Yeah, I worked David on 20, CW, of course. I couldn't make any phone contacts, but I did
Never
work,
could hear phone.
make 3 CW contacts.
I heard 30 pretty loud Wednesday afternoon. It was like an S5 or 6, but the pileup was just impossible.
That's 2 a.m. Sunday morning. It wasn't nearly as thick.
Oh, good. Well, that's cool. Did anybody take you up, Vernon, on your offer to help with the expedition?
Well, I hadn't had anyone come over yet.
I wish I had. All right. Any other announcements?
Just a question, how helpful was the DX Summit in the reverse beacon program?
Well, they're very helpful.
Use that?
Yes.
Yeah.
DX Summit.
The reverse
Right.
beacon is very good. I never thought about it until Dick suggested it, and you could always see what frequency they were on. And the DX Summit works good too, but the reverse beacon is just about real time.
Is everybody familiar with the reverse beacon?
Tell us about it.
We had a real good presentation on it, just
Yeah,
not.
I made a great presentation not too long ago, but just very briefly, there are a number of stations that have set up software-defined receivers all over the world. And the software-defined receivers are very wide bandwidth. and they're collecting information on, some of them on multiple bands, some on just a single band, but they're constantly collecting information through quite a wide bandwidth. And the computer in these receivers, these software-defined radios are connected to computers. That computer is looking for either CQ or test, T-E-S-T, in a digital mode, CW or some of the digital modes. And when it detects those CQ or test, then it looks for the call sign. And it's posted on the internet. So, you know, if any of these things are all over the world, if they hear a station transmitting, you can look on reverse beacon. You can use it yourself. If you're testing your equipment, you can send out a signal, you know, preface your call sign with either CQ or test. I usually use test because I'm not looking for somebody to come back to me. So I say test, and I usually do it twice to be sure that it picks it up. And I would recommend using a keyer or keyboard or something like that rather than a straight key, unless you're, like Paul can do his side swiper, it sounds like a mechanical key, but for me, I have to use either key or something like that. And send your call times 2 or 3 times after you send the word test, and you look on there and you can see who's picking you up. So if you're comparing 2 antennas, you can try it on one antenna and the other antenna and so forth. But it's really valuable. It's the reverse beacon network. And if you just simply search for a reverse beacon network, you'll find it.
And Dick, you might want to remember or remind the guys that Dave is going to be coming in May to give a presentation.
Yeah, we're hoping that. Yeah, we had originally scheduled for April, but we're not. We felt like he felt like there wouldn't be enough time for him to prepare. And I think they're going to spend another 6 days or something on South Georgia. So they're still, and they're 3 or 4 days from South Georgia. So it's going to be another 10 days or 2 weeks.
It's a total of about 6 weeks.
Yeah, it's still quite a, and we hope they, you know, can go on to South Georgia. It's going to depend on the condition of the equipment, I guess. South Georgia is a little bit more hospitable. There's a little settlement there, and somebody was telling me it was on the public TV last night. They had a little documentary, and I've seen one before about South Georgia, and it shows the old whaling station that I guess is no longer being used. But
how far is that from Thule, Greenland?
I think it from what?
Thule, Greenland.
Oh, I don't know, but that's Greenland would be
Not
in
very
the.
far.
Oh no, you think about Thule Island, not Thule, Greenland.
No, Thule, Greenland.
Well, Greenland's on the other side of the world.
That's North Pole. Oh, it's okay, it's not South
Yeah,
Pole.
this is close. About 600 miles. Thule Island, where they were, which is part of the South Sandwich Islands, is more or less south of South Georgia, and I think it's about 600 miles. So that's what the distance they have to traverse to get back to South Georgia. Any other announcements or comments or anything? Daniel's going to come and tell us all about robotics.
Oh, yeah.
So I'll let you.
So, Robotics and Radio. This was a bad idea I had last year when they were desperately looking for programs. I'm like, I can talk about robotics and radio. Oh. So I got put on the list. Turned out I was at a conference that week talking about this sort of stuff. So I got bumped, and then it got brought. Unfortunately, people didn't forget, so then I got put on the program for January. So a little about me. I've been an amateur radio operator since 86, 87. Periods of activity and inactivity, depending on what was going on in the rest of life. I work full-time for the state of Louisiana, and I'm a part-time PhD student at LSU in the Department of Biological and Agricultural Engineering, where I build robotic boats. So what you have here is this is our baby demo boat. We actually have 2 of these. The other one's about twice this size. This is not one of my research boats. This is one we take to show students and other groups. I was gonna bring one of the big ones, but the weather was just nasty, and I didn't want to manhandle the big ones, which are about 3 feet by 4 feet, into and out of the back of my truck and have to deal with it getting rained on. Not that it's not waterproof, it is a boat, but I would have to leave it sitting in the truck all night in my house. I didn't want to do that, so I didn't bring one of the big ones. I do have a couple of pictures of them. So I've got some pictures here. I don't know how well you can see these. These are some of the older. So this research has been ongoing since about 2005, no, earlier than that, 2001, I think was when they first started. And these are various iterations. There have been lots of iterations of these kind of one-off boats. The one that's kind of the smallest in this picture up here is kind of we still have this one. It's the only one of the old ones we have because I won't let anybody throw it away, because this is welded aluminum construction. This thing is a work of art done by the shop guy at LSU. And I'm like, nobody's throwing, I've got it hanging from a ceiling. Like, you're not throwing that away. This was the first one I got to play with when I started my master's program. This is another one that we have. And this is the biggest one we've ever built. And I was just coming in when they were building this one. So there's no good scale here, except this, I'll tell you, this thing is 9 feet wide and it's 12 feet long and it weighs just under a ton. It is powered by 8 deep cycle marine batteries. What's not shown in this picture is the whole top of this thing is covered with solar panels when it's fully assembled. It comes apart in pieces for shipping. And it's got 2 30 or 40 pound thrust trolling motors mounted sideways, and they replace the blades with paddle wheels. This rascal will not only move, you can ride on this boat. It's the only one of the ones we've ever built that you can ride on. Somewhere I have a picture, not in the presentation, but of the guy riding, the grad student that was working on this, riding around reprogramming it as it's going around the lake at the research station. So these are some more of the older boats. This is a one-off. This was a student senior design project that's based on the redesign that I did after I got there. And this is a picture of one of the boats that I use. So it's the same, except mine's not painted purple and gold, nor is mine, the frame on this one is powder coated. The girl who was on the senior design team had parents that owned an auto shop, and they powder coated the frame for her. Anyway, this gives you a little bit of sense of scale. So the design is a dual pontoon and it's dual paddle wheel. And you're like, well, that's not a very efficient way of doing this. But these boats are designed to operate in very shallow water, in lakes and in marshes and things like that. 2 problems. Props hang much further in the water than paddle wheels do. The paddle wheels are only down in the water a couple of inches. And props are notorious, if you've been out in a boat, they're notorious for getting tangled up. You know, think about what happens with your trolling motor when you run into a bunch of weeds and you end up having to pull it up, and well, the boat can't do that for itself, so we don't want to use technology that's going to get them tangled up. So this is the current fleet of 3 boats. I actually have frames built for 2 more, but they're not assembled yet. And this is a staged picture. If you look very carefully, you can see monofilament running across here to this boat. This was for an article that they put in the Ag Center's magazine. So we just pushed them out and then pulled them back in. But the electronics are enclosed in this tube. We actually use sewer pipe because it's really lightweight, and it's a nice, easy way to get the electronics fairly protected against water. I have one of the electronic boards out of one of these up here, and we're in the process of tearing all that apart and redoing the electronics with newer components. What you see on this end is a GPS antenna, and I have that GPS unit up here. And the back end is what we're going to talk mostly about tonight, which is the radio system. So this is the control system for the very oldest type boats. It was very simple. It used a low-end basic stamp microcontroller, a motor controller for each side, solar panels to recharge the batteries, and they used bump sensors. And this one up here has bump sensors. And when you all look at it later, if you come up and look at it, you can't see it in the light, but the bump sensors are camo. You know why they're camo on this one? Anybody want to take a guess?
Bass keep hitting it.
Huh?
Bass probably has.
So no. These are actually arrows. They're aluminum arrows that have been cut. This boat was built by a couple of high school teachers that came to work with us through a education program one summer. And they built 2 of these. They took one of them back to the high school where they taught, and they left one with us to use as a demo. But it basically has this same control system on it. And it's got a battery. It'll power up, and the bump sensors do work, so y'all can play with that later. So this is a block diagram of the newer control system, which has 2 processors now. So we're still using a lower end processor for low-level functions, motor control, things like that, with a higher-end processor with a lot more speed and memory to do higher-level navigation computation. We actually are upgrading this microcontroller to hopefully move most of that off of it, so that then the ARM system that runs Linux can be used. We're hoping for simple image processing. They tried image processing with these boats in the past because I guess I skipped a part. Their boats were originally designed to scare birds off of aquaculture ponds in Louisiana. Birds eat an enormous amount of profit off of these ponds, because aquaculture ponds, if you don't know, tend to be fairly shallow. So it's like a buffet. The birds just land, and there are all these fish or crawfish or whatever that can't get away because there's nowhere for them to go. So birds don't like these things. So there was an attempt to do image processing and figure out, oh, there's a bird, let me go chase it. The problem was, when they were first doing this in the early 2000s, by the time the computer figured out that there was a bird there, the bird was long gone and the boat had moved from its original position, right? It took several minutes to process an image. If you've never done it, processing an image on a water background is really, really hard, because there are all these crazy reflections that confuse the computer. It's not like looking at a picture on a white background that makes it really easy. So this is kind of the block diagram, and you see the radio here. You have 2 radios. There's one that's just a receiver, right, your GPS, and then you have a 2-way radio. So this is kind of the diagram, if you will. It's an ugly diagram. These are autonomous surface vehicle. We have to make it sound nice when we put it in papers, right? So the idea is each of these boats in the fleet, however many there are, can communicate with each other and with the land-based station. And in fact, the radios that we use in these will automatically route traffic. So if this boat can see this boat, but this boat can't see this boat, number 3 will route the traffic from 2 to 1 if it needs to. And that's actually built into the protocol in the radio itself, which is a really nice feature. So these are the radios that we're using right now. These are XB radios. You may have heard of them. They are readily available. There are a couple of really nice features about these. These are Series 2. It should say that on there somewhere. Oh, S2, right. So there's a Series 1 and a Series 2. The important thing to know is if you decide to play with these, Series 1 does not talk to Series 2, nor vice versa. So they all have to be the same series, and that has to do with the firmware that they're running. You can see this one has an antenna connector. It's a crazy antenna. It's a reverse polarity SMA connector, which is only a problem in that you have to be careful when you order things for it. But
Just like a Chinese handheld.
right. Yes, I have an antenna that won't fit those at home because I forgot to check. The nice thing about these is they come in several models that are pin compatible with each other at various power levels and various antenna connector designs. So there's one that's got an on-chip antenna. There's one that's got a micro FL connector that looks something like that, where you can plug into it. There's this one. They have them at, I think, 0.5 milliwatt up to the ones in here are 2 milliwatts. You can go, I think, much higher than 2 milliwatts. You have to change, the pinout changes. It's a different radio that you have to swap out, but they do make a 900 milliwatt version. So the radio that's in this electronics kit right here is rated at 400 feet line of sight. We actually tested it further than that, and it works pretty well. But 400 feet gives us enough range to do the testing that we're doing. Won't work. I mean, the eventual goal is to put these in like coastal Louisiana where they might be miles apart. But for what we're doing testing right now in ponds and large lakes, this works pretty well. They're in the 2.4 gigahertz band. They're spread spectrum radios. They offer 128-bit encryption. I'm trying to think of the other features that are available in these. They're pretty nice little radios. They automatically form a network when they power up. You define one node as a controller, and typically that's a land-based one that we've got attached to a PC so we can see what's going on out there as far as traffic goes. And then as each additional radio comes on, it associates itself with that controller. And once they're in a network together, they will pass traffic back and forth. This is a diagram that I blatantly stole from Zigbee's or Digi's site. They're the people that make these radios. So in every one of these Zigbee's networks, you have to have a coordinator node. Coordinator nodes then can talk to router nodes or end nodes. The only difference with these is end nodes won't route traffic, number one. But the other thing is an end node can be put to sleep to save power. You can't put a router to sleep because you don't know when it might need to pass traffic. So routers and controllers have to stay powered up. The end nodes can actually shut down. We've actually done a totally not boat-related project. I get sucked into projects every once in a while because my professor gets tapped to do something, and he's like, "Here, this looks interesting. Work on this." So we built a wireless irrigation system, and one of our big problems is power consumption because these things don't have solar panels, so they don't get recharged. And I started doing back of the envelope calculations on, okay, the Arduino is 65 milliamps, the radio is 20 milliamps, and I'm going, well, this is nothing. And then I'm like, wait, it's got to run 24 hours a day for 6 months. That's an 800 amp hour battery or something. I don't remember the number, but it was huge. And I'm going, that's not going to cut it. So we figured out how to put all of the end nodes to sleep when they're not actually working. And that lets us, we're still not getting the battery life we're looking for. And I'll talk a little bit about that when I show you some of the other radios that I have. The goal is to run these things for 6 months at a time on like a coin cell, which is really, really hard. There are other networks you can run on these. So this is the Zigbee network. You can change the firmware out and run a different network on them. But they're limited to these. They have 2 firmwares they'll run. So for my project, I'm trying to get these boats to talk to each other, and they have to exchange some information. And this is, if anybody's seen a NEMA string from a GPS unit, this is a blatant ripoff of a NEMA string, and there's a reason. You never need to send a $sign. So it makes a great start character. There's no, when am I ever going to need to send a $sign from one of these boats to the other? In the same way, we don't use semicolons in any of these internal things. So we can use semicolons as our stop character, which lets us have variable length sentences. And so this is just the specification for one of these sentences. There's a source number, a destination number, and all this is locational information. And what this does is let each boat not only know where the other ones are, but because it gets speed and bearing, it can actually project the course that another boat, so that if you've got 2 of them out there and they're going towards each other, they can figure out they're going to hit each other. That code, just by the way, I haven't gotten that implemented yet. I'm working on that part. Yeah. Feature to come. And then we've got space in the sentence to add environmental data. One of the things that I'm doing is hanging environmental sensors off of these boats, like dissolved oxygen, nitrate sensors, things like that, to look at the water quality and map it on a pond or other water bodies. So we want to be able to send that back and forth. There's a whole other communication system that's defined to between the two computers on board, but since it doesn't involve radio, we're not talking about that one. So if this works, this is an animation a student did for me of swarming behavior. You know, it might, I hope it works. I tested it on my laptop, but I'm not using my laptop. I don't think it's gonna run. Anyway, I'll describe it. So there are 4 boats. That red line up there signals where a source of contamination is. The idea is when this boat encounters that as it's rolling around the pond, it's gonna let all the others know, hey, there's something over here. I don't even know exactly where it is, but it's in this corner. So then the others will start moving in that direction, sensing for the same thing, and eventually they'll converge on the point of highest concentration in the pond. It's called gradient tracking, and that's kind of the ultimate goal of what I'm doing, but that's not a trivial thing to do. So a little more about the radios. This is a pinout of the XBs, and if you look at it, and if you're used to reading these things, you might notice they've got these pins that are labeled I/O. So the XB is actually a microcontroller in and of itself. So there's a radio in there, but it's also a microcontroller. So it talks to whatever you got hooked up with these data in and out pins, the DTR and CTS pins, and RTS pins. But you notice it's got a PWM pin that's pulse width modulation. That lets it control things like motors. These I/O pins, it can read sensor values. So you can build a standalone sensor module with just an XB. You can actually program it, set that thing to report like whatever that value on that pin is. Whenever it changes, you let me know. So you can attach these to like field sensors where it can sit out there and wirelessly send you data back. That's not how we're using them, so I can't tell you a whole lot about that because I haven't done the research on how to do it, but it is possible to do, and there are a lot of applications I'll show you. This is one off of Digi's website. So you can have both actuators and sensors talking to a controller that can make decisions about what needs to happen based on the sensor inputs. And you can write your own code. They've got a Java library if you want to write Java code, if you want to torture yourself by writing Java code. This was an application I found online. This Sumo bot they use them in education a lot, and there are competitions where these robots are built. They're real low to the ground, and they're very small. But the idea is they act like sumos. They try to push each other out of the ring. And so this one is a tilt sensor that I think is communicating back to that one. So they're using XBs for that. We're actually, I was telling somebody, we're entered into the robotics competition for ASABE, American Society of Agricultural and Biological Engineers. It's a professional society. This is our first year at attempting it, and the challenge uses 2 robots, and they have to talk to each other using XB radios. So I really, none of the group have ever built, other than me, have ever worked with robots at all. So it will be interesting to see if we can actually pull this off by July. So there are other radios out there besides XBs, and I brought some examples. I have an XB up here that y'all can look at. There's one on the board there. There's another technology called an Arduino. So this is an Arduino and a little radio in a tiny little package. I have some other modules up here. There's a programming module, I keep stepping on the mic cord. There's a relay module, and there's a power module that takes a CR2032 coin cell. So you just stack these things up and build whatever you need to. I do own this, but I don't have it here. These you can get so XBs are in the $20 to $30 range. Arduinos are more expensive than that. These things are $3.95, I think, a piece. They're from Marlin P. Jones. They're 2.4 gigahertz little radios. They're not nearly as complex as the XBs. They don't form networks. They don't do anything, but you can use them to communicate data from one point to another. They're basically point to point. They don't do networking. But they're really cheap if you want to play with, radio communication attached to like an Arduino or a Raspberry Pi or something. They're pretty simple. I mean, it's got 4 pins or 8 pins, I think, that you can use. You don't even need all of those. I think that's it. I think I've covered everything. I kind of blew through that. Does anybody have questions about anything I talked about? I wanted to give you plenty of time to get up and come up and poke around this stuff. I brought BeagleBone Black and a Arduino Mega. These are the replacements for what's on that board now. Just because they're more powerful and easier to use. I also brought some examples of the different GPS units we've used. These are the big Garmins that we're using on the boats now. These are really nice, but they're not at all cheap. And they actually don't make this one anymore. They draw a fair amount of power, which is one of our big concerns. Even with the boats normally have 2 15-watt solar panels on them, which on a bright sunny day can power the boat and recharge the batteries that are on it. But, we get days like today, and you're not getting any charging out of the solar panels. So it doesn't take long to kill 2 8-amp-hour batteries in that situation. Questions? Yeah, John?
Do they do any operating at night?
It depends on what we're using them for. So if you're using them to scare birds off of the water, you don't need them to run at night because birds don't roost on the water. So they actually, all of the older editions have a light sensor built into them, just detects ambient light. And the programs all had a mode of just putting them to sleep. The later programs, after we switched to using GPS units instead of the bump sensors to tell where they were, would wake the program up every so often and check where it was. And if it was getting too close, typically you'd define a boundary for it to stay in at night that was out in the middle of the lake. And so it would check. If I drifted outside that, let me get back in the boundary and then I'll go back to sleep. Just to try to keep it from getting stuck and tangled along one of the banks. Other questions? Yes, sir.
Have you tried image masking on your when you're doing image?
I didn't work on the image stuff. That's before my time, and frankly, I'm not fooling with that in my PhD.
Lower, you can do image masking where you're cutting out the whole surface of the water and then scanning a few centimeters above the water and up for birds.
Right. There are ways you can do some of that stuff, and the image software has gotten a lot more user-friendly than it was when they were doing this originally. But no, that's outside the scope of my PhD. I'm not
passive LiDAR.
Yeah, I'm not fooling with images. I'll be happy. I just want to get my PhD and get out of school. Yes, sir.
What is the programming environment?
So the original boats, basic stamps, are actually programmed in a version of BASIC. It's called PBasic. Those are from a company called Parallax. The basic Atom micros are also programmed in BASIC. The ARM processor on here runs a full embedded version of Linux. So the programming language there could be anything, but it's actually C on that one, which will probably be the same thing we'll use on the BeagleBone. And the Arduinos use their own language. It's sort of C-like. It's got a lot of similarities with C syntax, but it's just different enough to trip you up. Yeah, Robin.
I was looking at this XB, but
Hmm?
I've heard of XB before, and I see that they offer units that run anywhere from maybe 40 feet, 400 feet, all the way to 40 miles.
Yes, there's some very high-powered
So I'm
units.
sure the low-power unit doesn't require a license or anything. If you had a high-power unit, they don't. What's FCC say about those?
Don't they?
I don't know. I've never used one of the high-powered ones, so I have not even researched it. Yeah, the low-power ones don't require any special FCC license. I should have asked Charles that, because we have a guy that does. So I'm doing boats. There's another guy who's working on his PhD, and he's doing multi-rotor drones, and he's using some of the higher-powered ones. And I don't know. Yeah, I don't think he's using the 40-mile ones, but he's using one of the intermediate power ones. Yeah, 40 miles is a long way. The biggest problem that you have with the ones on the boats is they're so low that you get a lot of blocking for over very long distances. So we might, for long distances, we may end up using like GSM cellular or something to do data transfer where you can get a cell signal, which is also an issue.
If I remember correctly, they have units that do 2.4 gigahertz.
They have some 900 megahertz units, I know.
And I want to say 314 or something like that.
They might.
All ISM bands.
Yeah, so. Anybody else? Any other questions? Well, I'm done. Where's Dick? There you go.
Very interesting. Daniel's got some examples of the items he was discussing up here, so I would welcome anybody to come up. Is there any other business that we need to conduct tonight? Any reports from the exam session?
Yeah, we have 2 new texts tonight.
Great.
Unfortunately, the general did not make it. She's going to try again.
All right.
We'll make it.
Okay, whoops. Okay, well, we'll let everybody come and take a look at this equipment and.
That's what it's designed to do. But that's a demo that we'll put, we can put that in a decent sized tank. We keep a kiddie pond, a kiddie pool, one of those little, fill it up with water and throw that thing in and it'll run all day. It drives like a tank. Huh? No, it drives like a tank, so it's got 2 paddle wheels. They're going forward, so if you bump this, bumps it. Now you see it, they both start going backwards. And the second down, see, now it's turning a different direction.
Okay, all right.
It'll spin on the right. You basically, it'll turn on a dime, right? Right. It just spins and looks at it in one location.
Did you have fishing poles on this thing?
There you go.
You want to show some redfish for that thing?
So that's the RF, we know that's the battery.
Don't be afraid. They're going to be our lords and masters one day. They're going to take over. You want to make friends with them while they're this young, because when they grow up and take over, you want them to have a good memory of you.
I, for one, welcome our new robot overlords.
I for one, do.
Oh, the little XP? Yeah. They're running 20 or so bucks. I don't remember exactly.
May your batteries always be well charged and you never rust.
That's a microcontroller that handles inputs and outputs from the environment and drives the motors.
The straps are what's this?
Batteries go in there.
What's that?
And that goes in there. Yeah, and that goes in the long boats.
I got you now.
Yeah.
I'm trying to figure out all these parts and pieces.
Yeah. That all goes up in that sewer pipe.
Looks like something you stick on your arm or
Yeah. Excuse me. Except this thing is like, I think he said it was like $500. Wow. Yeah. One of these is under $100 if I remember correctly, and same way with the with this, and that replaces this single piece right here replaces actually both of these. If they need as they need extra inputs and outputs, they use one. They'll go to using one of these, and it possibly in addition to the inputs and outputs on the radio chip, on the radio's microprocessor. And then all they have to deal with is the little switch mode power supplies to step down voltage for from the 12 volts down to these, which tend to like 5 volts. Because this one's marked 5 volts. I think the Arduinos also use 5 volts. Marked. Yeah, 5 volts. And then I also have something else.
Once in a while, and I start getting bad data. And the only reason we put a GPS on the system in a greenhouse is because I needed a really accurate clock. So I'm actually replacing my clock. And then I put on there because this is a lot of data.
Everyone's standing in line to pay their dues. Take check, we take cash.
They have a video where you're seeing your discount. I saw the email.
One of those last
I'm telling you, I did. I did. My two sons had to go out there with these two stuff. They had to go out, now that was only like 60 with dust.